This is the second test of averages and mixtures. In terms of level of difficulty, this test would be an easy to moderate level of difficulty, and therefore about 7 questions could be attempted. And the overall time to attempt this test would be somewhere around 18 to 20 minutes. Looking at the questions, question one, for instance. Question one says Garima mixed 40 ml, 40% sulfuric acid. So 40% sulfuric acid, 40 ml is taken. That is mixed with 25% sulfuric acid, which is 80 ml. In what ratio the resulting solution? So in what ratio should this be mixed with 50% sulfuric acid solution to make overall 40% sulfuric acid solution again? Now see, no matter how much 40% solution we add to an overall solution of 40%, the concentration will not change. So basically we need to make the 40% out of these two. Now 25% solution mixed with 50% solution to make a 40% solution. If we aggregate these numbers, we get the volume should be in the ratio 10 is to 15 or 2 is to 3. Since 25% is 80 ml, 20 into 40 is 80. So this should be 30 into 40, which is 120 ml. And therefore, 50% solution that we need is 120 ml. But the question asks us, to this total volume, how much should be added? So this total volume was 120 ml. To that, 120 ml has to be added. So what is the ratio of the solution that must be mixed? The ratio of the solution will be 120 is to 120 or 1 is to 1. Now, in terms of level of difficulty, I'd say moderate level of difficulty. If you look at all the steps, that is, you include 40, then 25, then 50. But if you're able to just keep this 40 out for a bit, this is just a one-step allegation, and therefore easy question should be attempted in the test as well. In a chemistry lab, there are 3 solutions X, Y, Z of an acid. Concentration are 30, 40, and P%. If 200 ml of X, which is 30% acid concentration, is mixed with VmL of Z, Z is P% concentration, we get a solution of 60% concentration, whereas 250 ml of Y is 40% acid concentration, mixed with VmL of Z, which is P% concentration, we get a 62% concentration. Now, whenever we are mixing to get an overall solution, the concentrations, or rather the amount of the acid or the solute can be equated. So here we can say 30% of 200 plus P% of V. This will be the amount of acid in the solution that are being mixed. This should be equal to the acid in the total solution. So 60% of 200 plus V. So this can be written as 30 into 200, 6,000 plus PV is equal to 12,000 plus 60V. This is equation 1. In the second case, we can write 40% of 250 plus P% of V is equal to 62% of the total solution, which will be 250 plus V. So 40 into 250 will be 10,000, 100 plus PV is equal to 62 into 250. 62 into 250. 250 can be written as 1000 upon 4. So this will be 31 by 2, which is 15.5. So 15500 plus 62V. This is equation number 2. Now what we do is we subtract equation 1 from equation 2. 2 minus 1. 1000 minus 6000 is 4000. PV cancel. 15,500 minus 12,000 is 3,500. Plus 62 minus 60V is 2V. Which means 2V is equal to 4,000 minus 3,500, which is 500. So V is 250, 500 upon 2. We have to find the value of P. So what we can do is we can substitute it here. We can say 40, or rather, if we look at this situation, this volume is 250 as well. Now we are mixing 40% and P percent in volume 1:1, 250, 250 to get overall concentration 62. 40 minus 62 is 22. So P minus 62 should also be 22. So P becomes 62 plus 22, which is 84. You could also substitute V in any of the equations to get the answer of P, which comes out to 84%. There are at least 2 or 3 steps involved, and therefore I'd call it a moderate level question. May be attempted, may be left, depending on time availability, but it will easily take 2.5 minutes to solve. A milk vendor has 2 cans of milk. The first contains 25% water. So can 1, 25% water, rest milk. So second contains, can 2 contains 50% water. How much milk should he mix from each of the containers so as to get 12 liters of milk with ratio of water to milk as 3:5? So basically, if we aggregate these two, we should get this concentration. Now, in the first can, the quantity of water is 25%. So this is 1/4 of the total solution. Here, 50% water means half of total solution. And if water and milk are in the ratio 3:5, that means 3/8 of the solution is water. So we can allocate 1/4, 1/2, and 3/8. 1/2, 1/4 becomes 2/8. 1/2 becomes multiplied by 4/8. So if we take the difference, this is 3/8 minus 1/8, which is 1/8. 4/8 minus 3/8, which is 1/8. So the volume of the two should be in the ratio 1:1. Since we need 12 liters of the solution, so they should be equally divided. So 6 liters and 6 liters should be mixed. As we can see, just one step of alligation. Hence, easy question. Even if allegation is something that we're not comfortable with, we can always say, let this be X%, X liters. So this will be 12 minus X liters. And therefore, 25% of X is water plus 50% of 12 minus X is water in the mixture. 12 minus X is water. This should be equal to total water. Total water will be 3/8 of 12 liters. From here also we can solve for X to get the answer as 6 and 6. Easy question, should not take more than a minute to solve, and therefore in the exam or a test this question should be attempted. A 100 ml flask contains 30%, 100 ml, 30% acid solution. What quantity of the solution should be replaced with 12% acid solution so that the solution contains 21? So suppose out of this 100 ml, X ml is removed, and therefore here we will have 30% solution, which is 100 minus X ml, and to this we will add X ml of 12% acid solution so that the mixture finally has 21% acid solutions. All we have to do is alligate these three. We are mixing 30% and 12% to get 20%, 21% acid solution. The difference here is 9. The difference here is 9. And therefore, the ratio of volumes of 30% and 12% should be same, or they should be in the ratio 1:1, which means total mixture is 100 ml. So this should be 50 ml, this should be 50 ml. Since 50 ml is being added, so 50 ml should have been removed. So what quantity of the solution should be replaced? 50 ml should be replaced to get 21% acid solution. Again, one step question. Similar question have been asked in exams earlier as well. Therefore, an easy question, something that should be attempted in a test or an exam, and ideally should not take more than 90 seconds to solve. There are 3 solutions. Solution 1 consists of A and B in the ratio 3:2. 2 contains B and C 1:4. 3 contains B and C volume 7:3. The 3 solutions are mixed in the volume X:3:2. If the percentage composition of A and B are equal in the resultant mixture, then what is the value of X? Now, in the composition, if the percentage of A and B is equal, then the amount of A and B also has to be equal. Also, the volume in which they are mixed are X:3:2. Now, if we look at the sum of the ratios in each solution, the sum here is 5, 1 plus 4, 5, 7 plus 3, 10. So what we can do is we can multiply the volumes by 10. We can say that 10x of solution 1 is taken, 30 of solution 2 is taken, and 20 of solution 3 is taken. Now this 10x will have A and B in the ratio 3 is to 2. So we split 10x in the ratio 3 is to 2. 3 is to 2, so 3 by 5 of 10x, which will be 6x. So if A is 6x, B will be 4x. This 30 will get split in B and C in the ratio 1 is to 4. 1 by 5 of 30 is 6. So if B is 6, C will be 24. This 20 will again get split in B and C in the ratio 7 is to 3. So 7 upon 10 of 20, which is 14. So B is 14, C would be 6. 20 minus 14. Percentage of A and B is same, so amount of A and B should be same. In this total mixture, A is 6x, B will be 4x plus 6 plus 14. A and B, if the percentage is same, the amount should also be same because we're looking at the same mixture. This gives us 2x is equal to 20 or x is equal to 10. So the value of x here should be 10. If mixed in the ratio 10 is to 3 is to 2, we will get a solution which will have A and B as the same quantity. Again, if you look at the level of difficulty, the question is not very difficult. The numbers are easy. They are easily dividable in the sense that, if we multiply this by 10, getting a ratio of 3 is to 2, 1 is to 4, 7 is to 3 is not difficult. And then we are just equating A and B. So not a difficult question, should be attempted in the exam. And since the solution is not very calculation intensive, should not take more than about 90 seconds. Ramesh and Gautam are among 22 students who write an examination. Ramesh scores 82.5. The average score of 21 students other than Gautam is 62. So 21 students plus other than Gautam. Ramesh. Sorry. There is Ramesh, there is Gautam, and then there are 20 students. Suppose the average score of these students is X. Now, the average score of 21 students other than Gautam, that is 20 students plus Ramesh, 21 other than Gautam, the average is 62. So we can say 20x score of the 20 students plus Ramesh's score is equal to the score of the 21 students, which is number into average. From here we can get the value of x. Second, the average score of all 22 students. 22 students will include Ramesh plus Gautam plus the 20 students. This is one more than the average score of 21 students other than Ramesh. So we can form an equation for this. The average of 22 students will be Ramesh 82.5 plus Gautam plus 20x, total score of the 22 students, upon 22. This will be equal to 1 more than the average score of 21 students other than Ramesh. So Gautam plus 20x upon 21. We can substitute also the value. For example, from here we can write 20x is equal to 21 into 62 minus 82.5. The value of 20x can be substituted to get the value of g. But again, this becomes very calculation intensive. So this method in itself can be avoided. What we can do is we can compare the two cases when one of the person is removed. So the first case is when there are 22 students, or rather, I say there are 21 students, which include 20 students plus Gautam. If Ramesh is included here, the average of everyone will increase by 1. The average score of all 22 students will be 1 more than the average score of 21 students other than Ramesh. Now Ramesh has 82.5. Whatever the existing average is, that is, whatever average, suppose each of the student here has X marks with them, the average score, 21 students. Ramesh will have to give 1 mark to everyone so that the average for everyone becomes X plus 1. So Ramesh has to distribute 82.5 minus 21. 21 is to be distributed. So after Ramesh gives each of these 21 students 1 mark, Ramesh will be left at 61.5. So the average of the 22 students is 61.5. Also, now if we look at the 22 students, each of them has 61.5 marks. These are 22 students. Now, if Gautam goes from here, everyone is left with 62 marks. That is, everyone increased by 0.5. That means out of 62 that Gautam had, Gautam would have given 0.5 marks to the remaining 21 students. Out of 61.5, 22 students have 61.5 each. Out of 61.5 that Gautam has, when he goes away, he will give half a kg to each remaining 21 students, so that everyone now has 62 kgs apart from Gautam. So Gautam will go away with 61.5 minus 10.5, which is 51. So what is Gautam's score? Gautam's score is 51. If we understand the concept of weighted average, this is a question that would be a moderate question. Similar questions have been asked in the examination. So if you are doing this, should take about 2.5 minutes to solve. Otherwise, if we are calculating using the formula for averages, the calculation might be a little intensive, and therefore moderate to moderate and difficult will be the level of this question. A packet of toffees is distributed in a class. A child who receives 1/8 of the total number of toffees. So first of all, let the total toffees be 8x, because we have to calculate 1/8 of that. So the child who receives 1/8 of the total toffees, 1/8 of 8x is what the child will receive, gets 5 times the average number of toffees received by the remaining children. Suppose the number of children in class is n. So the person who gets 1/8 of the toffees gets 5 times, so 5 into average number of toffees received by the remaining children. What is the number of toffees that the remaining children will get? The person who gets 1/8 of the toffees gets x toffees. 8x toffees were there, so remaining toffees is 7x. And the remaining number of children is n minus 1. So the average number of toffees with the remaining children will simply be 7x by n minus 1. 7x toffees remaining, n minus 1 children remaining. This means x is equal to 35x by n minus 1. X and x cancel, n minus 1 is 35. So n is equal to 36. So the number of students, what is the strength of the class? The strength of the class is 36. This is an easy question. The statement might be a little misleading. Otherwise, there is just one line of calculation that needs to be done and the question will be finished. Ideally, something that you should attempt in the exam. The concentration of orangeade in 72 liters of orangeade water solution is 40%. 72 liters of solution, 40% orangeade. 4 liters of the solution is replaced with water to form solution B. Then 6 liters of solution is replaced with water to form solution C. Again, removal replacement question where water is being added. So we can write the formula for removal replacement for orangeade. What is the concentration of orangeade in the solution C? So final concentration of the solute that is not being added is equal to initial concentration into 1 minus volume removed upon total volume into 1 minus volume removed upon total volume. So the final concentration will be 40% into 1 minus 4 upon 72 into 1 minus 6 upon 72. This becomes 40 into 1 by 18. 1 minus 1 by 18 is 17 by 18, 6 by 12, 11 by 12. So 10, 3, 5, 2, 9. 85 into 11. 85 into 11 will be 5, 9, 35.27. Threes are 81 minus 12, 125. Fours are 108 minus 17.0. 6 are 642, carry forward 4. 162, 80. Threes are 81. So approximately 34.63% orangeade will be there in solution C. Again, it is a direct application of a formula removal replacement. The subtopic here will be removal replacement. should not take more than 2.5 odd minutes. The only point could be that calculation is involved a little bit. Otherwise, just put in the formula and get the answer. The formula may not be very clear to all of us, and therefore I'm saying moderate, but otherwise, this is certainly a question that should be done in the exam. In a class, there are 40 boys, 32 girls. Boys, girls, 40, 32. This is the number. Average height of boys and girls is in the ratio 10:9. Average height is 10x and 9x. Find the ratio of average height of the class to that of the boys. So first, let us find the average height of the class. Average of class will be total height of boys plus total height of girls upon number of total height of girls upon number of boys plus number of girls. This will be the average of the class. So total height of boys will be 40 into 10x plus 32 into 9x upon number of boys plus girls will be 40 plus 32. So this becomes 400x plus 288x upon 72, which becomes 628x upon 72. This is the average of the class. We have to find the ratio of the average height of the class. 628 upon 72, 620, 620, this is 288, 688. So the average height of the class, so the required ratio is 688x upon 72. This is the average of the class to that of the boys. Boys average was 10x. And therefore the required average becomes 688 upon 72 into 10, which is 720. So we have to divide from the option. 720 can be a multiple of 45. Also numerator is less than denominator. So the answer should be option B. But in any case, if we divide by 45, 45 into 2 is 90 into 8. 688. 688 divided by 16 is what we'll have to do. 16 fours are 64 minus 48. 16 threes are 48. And therefore, this will be 43 into 16. 16 cancels. So the required ratio is 43 upon 45. Again, in terms of level of difficulty, I'd say it's a moderate level of question because some calculation might be involved and the language sometimes can be a little confusing. Otherwise, a decent question should be able to, you should be able to complete this question about 2.5 odd minutes. You should be able to attempt the question. There are three measuring jars, J1, J2, J3. First, J3 is filled with water, then emptied into a vessel A. Then J2 and J3 are both filled with milk and emptied into another empty vessel B. Finally, J1 is filled with milk drawn from B if the capacity of J1 lies between 3 to 8, at least 3, at most 8 inclusive, 3 and 8 both inclusive. J2 is at least 6, at most 12. J3 is at least 7, at most 14. Suppose the exact quantity of J1, J2, J3 are A, B, C. So what happens is in vessel A, capital A and capital B, first J3 is filled with water emptied into vessel A. So this will have C liters of water because of J3. Then J2 and J3 are filled with milk and emptied into another vessel B. This will have B plus C of milk. Finally, J1 is filled with milk drawn from B. So from here, this amount of milk is drawn. Milk left will be B plus C minus A. And J1 is filled with this. J1 is filled, that's it. Okay. J1 is filled with milk drawn from B. So J1 has A liters of milk. Vessel A has C liters of water. And vessel B has B plus C minus A liters of milk. Then the volume of water in A, C upon as a percentage of volume of milk in B, B plus C minus A. Is at most. We have to maximize this value. C upon B plus C minus A as a percentage has to be maximized. To maximize, the denominator has to be minimum, that is for sure. Therefore, A should take the maximum value. A can be a maximum of 8. Denominator minimum, B has to be minimized. The minimum value of B is 6. This is for sure. Now we have to look at C. Let us again, if there is a confusion, we can make two cases. Ideally, C could be of two extreme values, either 7 or 14. So I'm making a case with 7. 7 upon 6 plus 7 minus 8 into 100. This becomes 7 upon 13, 7 by 5 into 100, which is 140%. The extreme other case will be 14 upon 6 plus 14 minus 8 into 100, which will be 14 upon 20 minus 8, which is 12 into 100, which will give this a value of 7 by 6. So this will be 116.67%. And therefore, clearly 140% will be the maximum value at one extreme end when G3 has the minimum value, so that the denominator is minimum. As we can see, difficult question because it involves maximizing, minimizing. The calculation may not take time, but getting the right value is a challenge, and therefore a question that can be avoided in the exam. If we look at the overall analysis, it was an easy to moderate level of difficulty test where 7 questions would be a good attempt, and those 7 questions would ideally be 1, 3, 4, 5, 7, 8, 9. 1, 3, 4, 5, 7, 8, 9 would be this should have been attempted 1. This could have been left. Should have been attempted 1, 3. 4 should have been attempted. 5 should have been attempted. This could have been left. 7 should have been attempted. 8 should have been attempted, direct formula, and then 9 should have been attempted. This would give you 7 attempts, which would be a good attempt.